Welcome everyone. This is a video talking about a parametric handle-based design. As in this example, we have a pallet that when we pull on our handle, it will parametrically size by handles instead of going into your traditional Excel-like tables or parameter tables to type in variables to adjust it. You can use handles to drive it. This presentation is to extend on this to use some of our intelligent design capabilities. For example, we can drag and drop a component out here and it knows how to automatically position and size based on where it's dropped. And it can tell that there's pattern elements on here and ask you whether to pattern it. We'll just go ahead and don't show this again and don't pattern it anymore. But we can go ahead and repeat this on all four corners, and you can see that it automatically knows where I'm dropping. It knows how to position and place those elements onto this. Not only does it do that, it also connects it so that when I size this, those will automatically size as well and adjust. So this presentation is really to show how do you build this model? What's it take to build the parametric pallet example, and how do you build the intelligence so that these can drag and drop and automatically size, position, orient, and maintain those adjustments when we modify the model. So we'll walk through a presentation basically on how to do this so that you can use it in your own designs and your own products. So let's go ahead and start with a new scene. So I'm going to go ahead and change this to millimeters. So this was just a nice little pop-up option we have down here. But anyways, we'll go ahead and set it to millimeters, and we'll go to our starter catalog and just drop out a basic block, and we'll start with some sizes. So let's go ahead and set this out to 1,000, and if we zoom out a little bit, we can see that we want to set this about 100 for the width and let's say 200 for the top. So that's basically setting our base for our product, and we want to use this parametrically. So how we do this is basically go into our IntelliShape feature. If you right click, you'll see an option called parameters. This is kind of a starting point for our parameters. So let's go ahead and add a parameter. We're going to call this, for B for base, we're just going to call that length, base length for LEN for length, and let's go ahead and type that in as 1,000 is what it's set to right now, and hit OK. Now this just creates an expression for us, or a parameter for us, that's not tied to anything yet. So we'll just go into the IntelliShape again and right click on it, and you go to the IntelliShape properties and you go to our handles. So inside of our handles you can actually tie these to formulas, which means parameters. So if we go ahead and select that option, we can set any one of these. In our case it's a length. We're going to set that to the B length value, and we're just going to set it to do either the start or end. You can just choose the end in this case, or start, depends on your model and how it started, but it's basically based on this arrow location, but we're just going to set it to the end and just leave everything else the default, and that would basically drive that for us. So for example, if we change this to 900 now and apply, that drives it. So let's go back to 1,000 just to keep it easy for us for some other calculations later. We'll set it to 1,000. Okay, so that's what we did for our first one. I'm just going to size this a little bit smaller, and I'm going to go ahead and add another part out here and do the same thing for our planks, or pallet planks, if you will. We're just going to right click and drag and drop. So if you right click and drag and drop, if you don't know this, you can do this in the process and it'll give you a pop-up, and in our case we want it as a new part. And again, we can just go ahead and size this. We need it to be about 100 wide. Go ahead and set to 500 long and 20 for the thickness on that. So again, we're going to repeat the same process because we want this to parametrically size as well. So we'll go ahead and do the same thing. Select onto our IntelliShape. We got our parameter table open already, so we can just go ahead and add a parameter at that level. And this one's going to be, we'll call it the pallet length inside of here. And we set that to 500, hit OK. And just repeat the same process. Go to the IntelliShape properties, size box, show formula, and give it the same name that we typed in there. And we can do the end there as well, and hit OK. So basically both of those are set up, and you'll notice when that happens, I didn't show it in the other one, but notice that handle changed from these red or yellow colors to a blue color. It's basically indicating that it's being driven by something, so it's parametrically driven in this case. So if you try to pull this, it'll tell you you're going to break a parameter, but in our case we don't want to pull it. We're just going to use this to be driven by some things else later. So now that we have this, let's go ahead and just close this for now. What we want to do is make our pallets along here and our beams along the bottom. So we'll just go ahead and select our object, and some things we want to do is we want to position this to a better location inside of here. You can do this in a number of ways. If you go up to your assembly menu, for example, we have a position constraints, and we're just going to do a point to lock that down, hit OK to apply that. So it's basically just applied our constraint right at that location for us. So it's going to maintain that if this moves or changes, but we have that fixed. Next, we're just going to turn that on, select our triball, and we're going to pattern that out. We know it's 100 there, so we're just going to create a linear pattern We'll just do 10 of those at 100 each. That will give us our 1,000 for us and set it along the length. And we'll do the same thing for our bottom one here. And we're going to create 3 of these out here. If we go ahead and create a linear pattern, we'll say 3 of those at 200. It'll create that total length. So the total distance here is 200 between those in our spacing. So now we've got our base here, and now we want to basically make this an assembly to do the handle driving capabilities. Now, if you remember in our first video, there is a trick to do this. So I always just create another object out here. I'm going to start with a basic block in this case. I'm going to drag and drop it again with a right click and create it as a part. And then you can see kind of its orientation. I'm going to rotate it up here just 90 degrees because I know my sketch plane is on that bottom location there. If we look at it, there's our arrow down there pointing on our bottom. And just basically to start off with, I'm just going to size it as the same size as our current assembly here of parts. Pull this out and snap to these locations. And just do our overall height here and snap it. So we basically got the overall size of that thing. The reason we're using that block is that's what we're going to use to set the assembly handles to be parametric. So if you mentioned before, as I mentioned before, these objects that got parametrically controlled changed their colors when we did that. We want the same thing to happen on this block. We want these length and width handles to be parametrically controlled. And we don't really care about the height. We're not going to change that in this example. So what we're going to do is basically create this guy, make it an assembly. So we have it sitting under here as an assembly. And one thing I always do at the start is just go to the part properties and basically say don't include this in the BOM, because this is a part that basically will not be shown anywhere. It's just used for reference in our case. And at this stage, we're going to go back to our assembly, right click, go to assembly properties, and into the size box. And this is where we're going to turn on the handles that we want to use as a parametric handle. We want to use that length handle, and it's going to tell you it's going to make these parametric underneath the children. So we're going to go ahead and hit OK, and we'll do the width as well. And we'll have it go ahead and show the box for those. The other things we want to do is make sure there's no locks on it, so that they don't size together. They're independent of each other. And we want it to size about the opposite handle, not from the anchor, just from the opposite handle for all those. And if we want to, we can even turn off some of these other handles so there's no order switching that goes to the height. It doesn't exist, so we don't even want it to go there. So we'll just set that to 0 and hit OK. And so what we're going to see is we now have handles on our assembly level. When we select that, if we select down to our box and even down to the block, you'll see all those now got controlled to be blue. And that's why we don't want to do it we don't want these patterns to be underneath there when that happens, because it would reset all those parameters that we set up. So we only wanted to set just the block, so that if I pull these handles, you'll see that block is going to change with it. But we haven't set anything else up to move yet. We'll get to that. Okay, so now we got the base of our handle set up to drive here. And now we want to drive our assembly with these patterns and these boards. So one thing I'm going to do is I'm going to go ahead and suppress this block because I don't need it anymore. I just got it used as the reference to begin with. And I need to move these patterns under here. And just one trick to move patterns is to basically select both of them, create a temporary assembly for those, move it into your assembly, and then just disassemble it. That'll move those patterns around easily. So now that we got those patterns in here, we now need to tie it up to this assembly. So we need to know what the size of these handles are and drive the pattern below it. Okay, so the way we do this is we'll just go back to that parameter table. So we right clicked on the assembly, went to the parameter table, and while we got the assembly selected at the assembly level, we're going to go ahead and add 2 parameters. One, we're just going to do the top length of this product, and we're just going to set it to actually just leave it 0 for now. Go ahead and set it to 0, and we're going to add another parameter called width, and that's going to be the width, and we're going to leave it at 0 as well. So what we want to do is we don't want to use the parameter table to type in values to drive things. We want it to pull from the handles, and to do that is it's a simple expression. It's basically saying grab your size box, and then which size box do you want? You put 2 slash there, and we want to do on this one, we want the length handle, so we just type in length. If I can spell that right, there we go. Type in length, and you'll see that it automatically pulled the current value for that. And we'll do the same thing for the width. Make sure I'm spelling right today, and there we go. And it pulled those values in. So those are basically automatically pulling the value of those handles. So whenever that handle changed, those values will update. And just to give you an example of that, if I select this guy and pull it, nothing else is being driven, but you can see those will automatically update. See that value up there, automatically update for us. So let's go back to 1,000 there. So now it's all set. So now we're going to go ahead and say show all parameters, because now we want to start driving the objects below it. And one thing to do for those patterns, it makes it easy, is actually give those a name. So we know the 10 here, this is going to be our plank number, and that's going to be the plank distance. Just make it PN and PD, and this is the board number, and this is the board distance. So I just give those real names so I kind of get a better idea of what I'm working with inside of here. So now that we have this, these expressions, so we just want to drive these various things when those things change. So we'll go to our board length. We know it's 1,000. We want it to be set equal to that length. So we'll just type in the length for that one, and the same for the width. The plank length is actually the width value, which is 500. We'll drive that. Now it's just a matter of driving our pattern elements. And this is just some simple math for both of these. So for the plank number, it's going to be the length divided by, where we go? There we go. 100 millimeters inside of there. So you can say your total length divided by 100 millimeters, that's going to give you the 10. So that's all we need to know, is like every time this grows 100, just divide it by 100 millimeters, and it's going to give us another board plank inside of there. So we'll set up this to snap at all 100 millimeter increments in this case. If you had something that's variable, then you may have to adjust that or adjust your sizes of your planks to be more dynamically sizing, if you will. But in our case, it'll be a simple example for this. Okay, next we need to go and do our pattern spacing for the bottom boards. So we know the total of this is just a mathematical formula. We're going to take we need to know these two distances here to calculate the spacing. So we need to subtract 1 and divide it by 2, essentially, is what the formula is. So we're actually going to go into our board distance here. We're not going to change our numbers. It's always going to be 3. We just need to calculate the spacing. So it's going to be the total width of whatever the width of this box is, minus the width of one of these boards, which in our case is 100 millimeters. And we're going to divide that whole thing. So we're going to put parentheses on both of these elements here, and I'm going to divide it by the total board number minus 1. And again, we'll put those in parentheses because we want that to do that as well. Just simple math. So we're going to subtract 1 from the board number, which gives us 2 boards, minus the total distance here, minus 1 of these boards will give us that calculation of 200. So if I click out of this, it should still be 200. So there we go. Okay, so we kind of set up our values here. And now if we go and hit OK to apply that, we can now go into our handles and right click on one of these, and we can say change snap increments. And one of the options here is to set what the linear snap increment is. In our case, it's going to be 100. And you can also choose to have this snap by default if you want on, or you can just hold your control key to do it. I just use the control key in my case and hit OK inside of there. So now if I hold the control key down, let's pick this guy, hold the control key down and drag, you'll see it'll snap by 100 increments, and we see our boards automatically apply. And I can do the same for both handles if I want to do it dynamically, or just select one of these handles and just pull this one. It doesn't have to be 100 in this case. It can be any increment on the width because our boards are just sizing, and you can see our calculation is automatically spacing that out. So anyway, so now we got this parametrically driving our box. So this is very similar to what we did before on our other example, but now we want to add the intelligence. So how do we add intelligence to it? Our intelligence is being used by what we call attachment points. So attachment points are just indicators of where something is being placed, and then you can connect other things to it. So in our case, we want one on this corner, this corner, this corner, and this corner to drive a board that's going to come in, or a side plank, if you will, of multiple boards that comes in here and on the ends. So what we're going to do is first we're going to put one on this top board and on this corner so that it moves and stays in this location. So if we just rotate around, because the way IronCAD works, when you drop on a face or a point, it's using the current viewing direction, the way we're looking at our screen, to determine what the up direction is. So if I'm looking right now, the up direction is towards my right side of my screen. If I move it like this, my up direction is actually the top of this board, or towards my face. So in our case, I'll select my assembly, select attachment point, and I'm just going to pick that point right there. And you'll notice it comes in the right orientation, pointing up. In our case, the X is going to the right. So this gives us our starting location of where we want something to connect to our pallet. Now, if you select on your assembly, right click on it, you can select the option Set Name and Behaviors. This allows you to give this intelligence to this attachment point. And this, we're going to call this the side. This is what our side is going to connect to. And you can use various connection types, like a male and female. This is more like a plug and a pin type connector if you want to use male and female, or you can just use a neutral, meaning anything can connect to it. It's just using, basically the way these things connect is using this x-axis and the z-axis. It basically aligns the x-axis when it drops another component onto it, and it anti-aligns the z-axis. Okay. So what we're going to use is this name as our identifier and how you connect, and then we're going to use parameters to drive it. So what we want to do is we're going to say when that side drops on there, we're going to call it the side length. We want that side length to be set to one of our variables that we have, which in our case we have two variables at the assembly level, which is the length and the width. So we want the long side of this to be the length in our case. And we can do it as a parameter expression, meaning that if our model changes, update this expression as well. So we're going to tell that to be using this length value, and we can use this as an expression and click add, and it'll add it over here to our list of connection types. And then what we want to do is, if we want to add constraints to this as well, if you want it to lock in that position, so if it moves with it, you can use a physical constraint to constrain that down as well. So we'll go ahead and use a coincident constraint in this case. And now that we have that, we want to use that same attachment point on our other corner here as well for this piece. So what we're going to do is just create a new catalog, select our assembly, move over our attachment point, left click, drag, and drop it into the catalog. So now we can rotate the other side. Now in this case, it's a little interesting. So this is a pattern, and if we grow this, a new board comes in. So I can't add it to this corner because that corner doesn't move. Another part will come in. We need to actually add it to the board that grows, which is this bottom board here, and then I'll just position it up into this point. So if we select our assembly, I can drag and drop out into this face. It doesn't matter where. I can then just use my tri-ball when I select down to my assembly, select that attachment point. Sorry, there we go. Select our assembly, select that attachment point, turn your tri-ball on, and then we can just move it up to this point and just rotate it and orient it the way we want. We want it to go up, and we want it to turn inwards 90 degrees. Okay, so if we select off here, we can see there's our two attachment points, and that's going to control our side. Now what we also want are these width ones as well, and they're going to be slightly different. So we can do the same thing. Now in this case, it needs to grow with this assembly, so this board is going to be the one that's going to grow as the top one there. So we'll select that assembly, drag and drop it onto here, and again we can select that attachment point, turn our tri-ball on, move it up to this point. Again, let's move it vertically, and we're going to turn it the X so it's pointing in this case 90 degrees. Now in this case, we actually have a board that has a thickness inside of this, so we actually need to move it in or offset it. That board thickness was 20 if we recall when we built that, so it's going to move it in 20 inside of there. Okay, now this attachment is slightly different, so let's go ahead and edit this name and behaviors. And in this case, we're going to change this side length parameter, so we're going to drive it slightly differently. We're going to use the same parameter value, but instead of using the length, we're actually going to use a width value. Okay, so we're going to say use the width value instead of the length, and we need to subtract 20 on each end of the new part that's going to come in there. So we're going to subtract a total of 40 millimeters, and we're going to say modify that expression. So now we have a new expression for this attachment point, and we hit OK. So we can see this one's a little bit different. It's going to do the same exact type of behavior. So again, we'll drop that into the catalog, and we're going to move it over to the other side. Again, in this case, this board's going to move out, so we're going to drop it onto this board, so it needs to know to shift and adjust with this guy, or drop it on the edge. You could have dropped it on the edge on the other one as well, but we're just going to drop it on this edge. Again, select it, use our tri-ball, move it up to our point here, and I would kind of take a look to see how we're situated. Looks like the Z is down, so we're going to have to rotate that 180 degrees. 180. And we're going to have to rotate it 90 degrees inside of there. And again, it's going to need to be moved in 20 inside of there. And if it ever gets locked in this situation, you just hit recreate display, and it'll update itself to get it showing in the right location. So now that we have these attachment points basically set where we want, we now need to build our other element. So let's go back to our starter catalog, and again, let's just drop out a block, and let's go ahead and size it. And we'll say again, let's just start with let's just say 900 long, so we can see this thing adjust automatically for us. And we know this is going to be 20 thick board, and we'll set it to 100 length plank. So it basically sort of the plank elements is this one. Same thing as we did before. We can start adding the parameters to this. So we can go to our parameter table, add a parameter, and this is going to call our, let's call it side length, if you will. And we said that was, I think, 900 inside of there. Hit OK. Go to our IntelliShape properties. So this is kind of repetitive, but you can get the idea. We'll go in here, set this to end, set this to our side length inside of there. Hit OK. And now we're driving that plank. And now we've got that plank, we can go ahead and make a copy of it. I'm just going to copy it up here. You can make a pattern if you will, or if you make a link, it doesn't really matter, but let's go ahead and make that, let's say 400 spacing inside of there. And in our case, we're going to use this board and build another one. So I'm going to take that board, use the tri-ball, I'm going to rotate down, make a copy of it, and we'll just say rotate that 90 degrees. And we got it in place. And for this particular board, we're going to change its value here to, what did we say that was 400? So it'll be 300, I think, in there. Let's say apply. Yeah, 300 in length, just to show that adjustment. So one thing we want to do, I just kind of move this board out a little bit, is we do want to connect it to be positioned in the right location. So again, we can use those assembly mate and line position tools because we want this to be connected and move properly. So in our case, we'll just do some position constraints. We'll take the top piece, make it connected to that corner there, apply that, and take the bottom one, apply it to that corner, and lock it up. Okay, now that we have that done, we can take that, make a copy of it, make a copy, hit OK, and then we just need to do another position constraint for this one to there, and we're done with that. So we don't need to do the top, it's already positioned in there. And last we need to do is we're going to build a side member here. And this is kind of an interesting way to build this, but basically I'm just going to do a sketch of my part, and I'm going to reference the existing edges to drive my shape. We can start with a block out here to do this. Again, you can right click, drag and drop it out, drop it as a part. In our case, we're going to reverse it because we want the sketch to go the other way. So let's go ahead and reverse inside of there. Let's move it up so we can see what's going on. And we know that thickness is going to be 20. And now we can just kind of use our sketch dimensions to drive this. So to go into our sketch, we just go into the IntelliShape, right click, edit cross section, and now we're in the sketch mode. So the first thing I'm going to do is I'm going to project constraint, construction geometry, just these 4 edges as I'm going to use as my driving geometry elements. Next, I want to make this thing work just like a box. So I'm going to lock these to be perpendicular, or you could use the horizontal alignments if you want, but I'm going to use perpendicular in this case. And I'm going to set a smart dimension here of 100 inside of there, and you can kind of see it size and adjust for us automatically, but we got that set. So now all I need to do is use a coincident constraint to basically align this up, because I know I need this top point to be coincident with that. I need this point to be coincident with that, so it kind of gives it an angle relationship. I can do the same thing for this bottom and this one to this side. And notice it has to maintain 100, so it just kind of moves the object to fit oriented inside of there. Of course, you can do mathematical formulas to drive certain heights if you want inside of here, but in our case, I'm just wanting to move and adjust and be coincident to both of those edges and maintain our height as it adjusts and sizes parametrically. So now I've built that shape, I've got it all ready, I can just hit finish. We now have our board. Now, one thing I didn't do in this one, I didn't make it look pretty yet, but we can go into some of our catalogs, our default catalogs, and go to textures. And if you go to this assembly, for example, you can drop a wood texture out here, apply it to all of it, go ahead and make it look like wood. And for this one, we can do the same thing. We want to make this an assembly, so let's go ahead and just select all these parts inside of here. And we're going to go ahead and make that an assembly. You can hit the S key or hit assemble up here. We got the assembly made, and now I can drop my wood plank out onto this and do the same thing. So we got our board, and we got our pallet built here. So now we need to do some things to this. One, we still need to build the parameters to this so that it will adjust from the assembly level. So we need to go to the assembly, go to the parameter table, and notice if we turn this off, there's nothing at the assembly yet. So we're just going to go ahead and drive this guy, and we really just need a length parameter, and we called that the side. If you remember, we called that let's go ahead back here. We want to set a parameter that's called side length. SIDE, capital LEN. That's what it's going to use to refer to drive this guy. So if we go into the parameter table again, for that assembly, we're going to go ahead and add a parameter. We're going to call it the side length. And currently we got that set at 900 or so. So we'll set that in there. And if we show all the parameters, we're going to use that to drive this overall length in this case. So it's going to be the side length inside of here. Okay, so that's what's going to drive this overall element. So for example, if I make this 800, hit apply, we should see that adjust. Okay, so that's basically what we're doing. We can leave it for 800 right now just to show what's happening. But anyway, so now we got this parametrically set up, ready to go. And now we need to add the intelligence to this to know how to connect itself by positioning and orienting and pulling the properties from the one that's going to connect to. So let's go ahead and close our parameter table. And we can simply just add a new attachment point on this, which is going to be on this front corners where we wanted everything to be related to. We can either build a new attachment point, or we can go to one of our catalogs here, reuse one of these and just rename it, re-edit its property names. Either one will work. So let's just go with a new one. We'll just add a new attachment point. We're going to add it down on this point. And now the X is along our length axis, which we want it to align to this red axis up here. And remember, I said it anti-aligns the Z. So right now the Z is up, and if it connects to this one, it's going to be pointing down on the board. So we do need to rotate that. So let's click it, turn on the tri-ball, rotate it down 180 inside there, and we got that thing updated. There we go, pointing down. So now we just need to give it a name. So we right-click on it, set name behavior, and for this one, it is going to be called that side, and we're going to do a neutral again. That's how that pairs them to. So it's going to look for a side in, and it's going to connect itself to it. We don't need to do anything else because it's all going to be driven by what it drops on. So how our smart intelligence works is basically it will take an element, drop on something else, try to find a matching element nearest the dropping location. That's what we'll do the orientation and positioning the information. It'll pull the values from whatever it drops onto, which is that attachment point, and apply it to your object. So you don't need to put anything on this one unless you can have something else drop onto that one at a later stage. So anyways, now that we have that, we should be able to drag and drop this into the catalog, or you can just drop it into the scene here, either way. But now we have it, we can just simply drag and drop out to test this, and you can see it automatically sizes and builds its relationship to it. So let's go ahead and delete this one, and just drop nearest our other location. So if I drop near this one, it would automatically position, orient to that side. If I drop onto this one, notice it positioned where it needs to be, which we gave it 20 millimeters, and it subtracted 40 millimeters to give us the overall length on that guy. And if we drop on this end near this edge, it will do the same thing on that location, positioned in the right location and spaced. Now that expression that we tied on there, so now if we go and change our thing, again holding our control key down, we can snap this guy out. Notice everything is being built as an expression inside of this. So if we adjust it here, it will also adjust. So if you look at your parameter table, you'll see all these expressions that we had before and some other ones being automatically built inside of there. So that side lengths were automatically being applied and expressions were automatically created for those to give you that behavior that this automatically sizes and adjusts after it had been positioned. So that's a very simple example of how to build this intelligence side of here. So basically we use attachment points and the naming on those attachment points to give very specific behavior for objects. So if you look at any one of these attachment points in here, I think if we edit one of these catalog items, you can see you can tie things like the name. That's how they find or pair each other. So the side and the way they connect. A neutral means it just connects to it. Male and female means they looking for a specific, a male is looking for a female and a female is looking for a male when it drag and drops out. The other options that we have here, you could give alias names if you wanted to say, this is the same attachment point on all locations, but this is we can call this one the width and this one the length. You could give it an alias name so you know which one's which. That's just for your own capabilities. These parameters, so you can use this to drive parameters that are tied to whatever level that you're on. In our case, if we run the assembly, it would show the parameter variables or referable variables, and you set it to what you want to drive. So whatever drops on here, its parameter name that you want to drive with that value. And you can do all types of math inside of there like I did on the other one. It has a width minus 400 millimeters. You can do that or any other type of math inside of there. Then you can get into advanced things by building the constraints so that when this moves, all these elements move and adjust and build a physical constraint. If you look in our scene browser, there is an actual physical constraint built there on the fly for us. And you can also do some other advanced things here that we didn't show, which is actually searching for a catalog. So if you had a element inside of here, you can drag and drop and search for a specific catalog element to connect to. Anyways, but you can see here, this is the constraints I was referring to. So it automatically built those constraints on the fly as it was being dropped out to apply those. So there's a constraint element from each one of these being applied, so that it gives us the behavior when it adjusts, it knows how to move properly and adjust. So hopefully you guys find this informational so that you can build your own designs and your own products using parameters and parametrics, and then using our handle-based driving capabilities and intelligence to quickly build assemblies and automatically drive them with handles. Thank you, and hopefully you enjoyed.